Hello everyone, welcome to my video presentation. So my topic is all about effective collusion. So we all know that all matters are made of tiny particles, atoms or molecules that are always moving and always colliding. But here's the key idea. Not all collusion causes a reactions. Only effective collusions do. So what is an effective collusion? An effective collusion is a collusion that actually produces a chemical reaction. That means that old bonds break and new bonds form and a new substance is created. As I've said earlier, that in order for a particle to react, it needs to be effective, needs to be an effective collusion. So in order to be an effective collusion, there are two conditions for our reactions. A is enough energy, and the second is correct orientation or proper position. In order for a particle to be an effective, it must have enough energy or the activation energy and the correct orientation or the proper position. So the first condition of an effective collusion is enough energy or activation energy. Every reaction needs a minimum amount of energy to start, which is an activation energy. So the key idea of this is energy is needed to break bonds before forming new ones. So here we have a graph presentation of a effective collusion. It is the chlorine and the hydrogen. So at the beginning or the left side of the graph, we have the reactants. So at this stage, most collusions are ineffective and because they do not have enough energy. As the graph rises upward, it shows the activation energy. This is the minimum energy required for reaction to occur. Here's the most important part. In order for a collusion to be effective, the reaction must have enough energy to climb this energy barrier and to reach the top of the curve. So if ang particles can have enough energy and they collide with the high kinetic energy, they will be able to successfully reach to the top of the curve. This means that the old bonds break and the new bonds begin to form. And this is now an effective collusion. Ang particles kay hydrogen and chlorine. So at the peak of the graph, this part it is the transition state. So kanina part, it is starting na ang mga bonds are partially broken and ang atoms are rearranging, and only collusions that have enough energy can reach at this point. So meaning if this collusion reaches the transition state or this peak, this means that it had enough energy and it is successful or effective. So after reaching the top, it forms a product and the reaction continues forward and the new bonds fully form and the products are created. So the products are created, which is the two molecules of hydrogen chloride. This confirms that the collusions are effective. So to sum it up, only particles that have a sufficient energy and reach the activation peak will only form a product. So now we are in the second condition of an effective collusion, which is the correct orientation and proper position. So even if the particles have enough energy, they still need to collide in the correct direction because molecules have shapes and specific reactive parts. So the key idea of this is that molecules must hit the right part, not just collide. So here are the example of the collusions not properly oriented and the properly oriented collusions. So first is not properly oriented, the collusions. So as we've seen na nitrogen dioxide wala na proper position, and when the molecule approach, the molecules separate, cause to have no products. While in the properly oriented collusions, they are properly positioned well. So when the molecules approach to each other and they break bonds, and it formed a bond which made a product of dinitrogen dioxide. So here are the difference between the ineffective collusion and the effective collusions in proper or the correct orientation or the proper position of every molecule. So there are factors affecting collusion efficiency. First is the temperature. temperature or higher temperatures increase the kinetic energy of molecules, leading to a higher frequency of collisions and a greater proportions of collisions exceeding the activation energy. So this means that a higher energy and that increase the kinetic energy of a molecule, since the temperature is the measure of the average kinetic energy of a particles in a substance, and this leads to a higher frequency of collisions. The second is the concentration pressure. The higher concentrations or higher pressure, specifically for gases, increase the number of particles per unit volume, increasing the frequency of collisions. So this means that the higher the concentration or the pressure for gases, it increases the frequency of an effective collisions or the collisions. So catalyst. A catalyst provides an effective pathway with a lower activation energy, allowing more collisions to be effective. So not all particles have high energy. Some of them have a low energy, and naapoy uban have enough energy to react. So without the catalyst, the activation energy is high. So only small number of particles can reach it. So that resulting to fewer effective collision and is slow. But with the catalyst, it serves as an alternative pathway with a lower activation energy. So this means that the energy barrier becomes lower. Why does a lower activation energy can have an effective collision? Because some of the particles who have lower energy can still react. So the particle can reach to the activation energy. For example, a hill. So if ang hill without catalyst, taas ang bundok or ang hill. So it results to a fewer na magsaka na ng mga tao. But with catalyst or smaller hills, kay daghan ang manaka or daghan ang saka or mag-hike ana na hill. The last one is the surface area. So in solid liquid or solid gas reactions, a larger surface area or powder with a solid block provides a more contact points for collisions. So simple example. So if we are eating a whole chocolate, di ba? Kay dugay na to siya makaon or dugay na to siya ma-melt. But if we break it into small pieces, kay dali ra na to siya ma-melt into our mouths, right? So muna siya ang example ani. In chemistry, for example, calcium carbonate plus hydraulic acid, which is calcium carbonate is a powder and hydraulic acid is liquid. So if we mix both of them, they react or it reacts easily or reacts faster. But if we mix hydraulic acid with a solid or with a marble or kanang rock, reaction is slow jud siya. When you break something into smaller pieces, you increase its surface or surface area. So in chemistry, in reactions, particles can only react when they touch each other. So the more exposed ang kana siya na part, the faster the reaction. A simple phrase explained sa surface area is that small pieces react faster. So to end my discussion, so let's have a conclusion. So an effective collision happens when particles collide with enough energy to break existing bonds and in the correct orientation, so new bonds can form. Most collisions fail because they either lack sufficient energy or occur in a wrong position. Only collisions that meet both conditions lead to chemical reactions, which is why the number of effective collisions determines how fast or slow reactions occur. So thank you for listening my discussion about effective collision.
I just had to let you know you're